So I'm going to go through and talk about key properties of logarithms. So there are three properties first that I'm going to talk about. The first one is the product property. So that tells you if you have log base b of uv, so u times v, what you can do is actually break this apart and make that log base u plus log base b of v. Okay, so that's your product property. The quotient property is almost identical, except now if you're dividing, you will end up subtracting the logs from each other. And then finally, the power property, what it tells you is if you have log base b u raised to a power, u raised to n, then you can actually move this n in front and it would look like this. So let's look at some practice problems. So one of the things I can do is to ask you to expand the expression. So for example, if I have log base 6, 36x squared, what I'm going to do is I'm first going to break apart the 36 times x squared. So I'm going to break them apart by adding the two logs together. So it'd be log base 6 36 plus log base 6 x squared. Then what I can do is, since this is x squared, I can use the power property and I can move the 2 in front, and that would give me log base 6 of 36 plus 2 log base 6 of x. Now, you could leave this as your answer, but you're not quite done, because if you notice, I can actually simplify log base 6 of 36. So 6 raised to the what equals 36? Well, 6 raised to the 2. So log base 6 of 36 is actually just 2. So whenever you have a number within your log and no variable, see if you can actually simplify that and figure out what it is. If it would give you a weird decimal or whatever, you can leave it, that's fine. But if it gives you a nice number like 2, just simplify. So for the second example, I'm given log base 3 of the square root of 9x. So the first thing I'm going to do is I'm going to get rid of the radical and make it an exponent. It's going to be 9x to the 1/2. Okay? Now, since I want to expand this, I'm going to move the 1/2 out front. So I have 1/2 times log base 3, 9x. 9x, okay? Now I'm going to break that apart because I can use my product rule. So I have 1/2 times the log base 3 of 9 plus 1/2 log base 3 of x. And just as before, I can recognize the fact that this is going to be a real number. So I have 3 raised to the what is 9. Well, 3 raised to the 2 is 9. So I have 1/2 times 2 plus 1/2 times log base 3 of x. And so I can simplify this and I end up getting 1 plus 1/2 log base 3 of x. Or you could put log base 3x over 2. So I have 3 practice problems for you here, and I'm asking you to expand them. So pause the video and do that. Now let's look at my solutions for this. So for here, I gave you ln of 6x squared over y to the 4th. So I'm going to use my quotient property, and I'm going to expand on this. So it's going to be ln of 6x squared minus ln of y to the 4th. I can further expand this because here I've got 6 times x squared. So I'm going to use the product property and make this ln of 6 plus ln of x squared minus ln of y to the 4th. Now I can use my power property. I'm going to leave this ln of 6. I'm not going to simplify this because I don't e to the what is 6. I don't know. It's not going to be a whole number. So I'm going to leave it as ln of 6 plus I'm going to move the 2 in front using my power property, 2 ln of x, minus, I'm going to bring the 4 out, 4 ln of y. So that's my expanded answer. For number 2, ln of 12 over 5, well, it's just going to be ln of 12 minus ln of 5 because I used my quotient property. Okay? And for the last one, log base 5 of x to the 5th, I'm going to first use my power property, so I'm going to bring the 5 out, okay, and then I'm done. Okay? So 1 was actually more complicated than 2 and 3. All right, another thing that can be asked of you is for you to condense an expression instead of expanding an expression. So for example, if I gave you ln of 12 minus ln of 4, I want to condense this, so I'm going to be using if we go back, I'm going to be using the quotient property. So this is going to become ln of 12 over 4, which is just ln of 3. And I can't simplify this because I don't know what e to the what power would give me 3. Okay, so I'm just going to leave it like this. For number 2, I'm given this. Now I'm going to be using my quotient property, but before I do that, notice I have 1/3 in front. So I'm going to first actually use my, if we look back, my power property. So I'm going to bring this 1/3 over, so it's going to be x to the 1/3. Now I can use my product property, and this would become log base 5 of 4x to the 1/3. Okay. Now I've given you 2 more practice problems to condense, so pause the video and do that. All right, so let's look at this. So first I'm going to use my power property. So I'm going to bring the 6 out and the 4 back in. So I'm going to have ln of x to the 6th plus ln of y to the 4th. Then I'm going to use my product property, and this becomes ln of x to the 6th, y to the 4th. Okay. For number 2, I've got this pretty complicated value. What I'm going to do first is I'm going to condense this part. So I'm going to use my, if you look back, I'm going to use my quotient property. So I'm going to divide 20 by 4 in order to condense this. Then for this guy, I'm going to use my power property. So I'm going to bring the 1/2 over. So I'm going to just raise this to the 1/2, or you could have raised it to the 0.5. That's fine. Okay. Then I recognize the fact that 20 divided by 4 is 5. And I'm going to use my power property again, bring the 2 over. So it's going to be log base 3 of 5 squared plus log base 3 of, well, what's 4 to the 1/2, which is the same thing as saying the square root of 4? Well, it's 2. I'm going to simplify this further. I've got log base 3 of 25 plus log base 3 of 2. And finally, I can use my product property. So this would be log base 3 of 25 times 2, which would be log base 3 of 50. And that 3 raised to the, it's not going to give me a whole number equals 50, so I'm going to leave it like this. Okay? So there are a lot of steps. Be careful not to make silly mistakes because they can really mess you up down the line. So just be careful and work carefully using your different properties. All right. Another thing you can do with logs is if, for example, you're given log base c of a and asked to solve it, well, if I don't know what that is because it doesn't give me a whole number, like here, log base 3 of 50, I don't know what that is. What you can actually do is complete what's called a change of base, use the change of base formula. So what you'll do is you'll take log of a and divide it by log of c, or you could take ln of a and divide it by ln of c. So, for example, if I give you log base 6 of 24 over 5, okay, what you would do is you take log of 24 over 5 and divide that by log of 6, because remember, this is your a and this is your c. And then you would just plug these into your calculator and you could get 0.875. Now, if you have a TI-84, you can actually just plug this into your calculator and solve it, so you don't need to know the change of base formula. But if you don't, then you can use this to solve it. So pause the video and use the change of base formula to answer number 1. All right, so here's my answer for number 1. Keep in mind log of a, this is my a, divided by log of c, so it's log of 48 divided by log of 4. Keep in mind, please be careful. You cannot just divide 48 by 4 and then take the log of that. That won't give you the correct answer, because remember, if I wanted to expand this, it would be log of 48 minus log of 4 in order to divide 48 by 4, not dividing the logs, so you can't do that, so be careful. All right, so there are 2 ways that you can solve exponential equations. So when you have your x as an exponent, 2 different ways. The first way is if you're able to manipulate your equation so that your bases are the same. If you're able to make the bases the same, then you can recognize the fact that if b to the x equals b to the y, then x equals y. Or you could take the log of both sides. So let me show you an example of both of them. Okay, for here, if I have 4 to the x equals 1/2 x to the negative 3, I recognize the fact that I can actually make these have the same base, and the base that they would have would be 2. So how do I do that? Well, 4, in order to get a base of 2, I'm going to take it, 2 squared is 4, so I made it 2. Okay, so 2 squared to the x equals, well, how do I make a half 2? It would just be 2 to the negative 1. So it's 2 to the negative 1 times x minus 3. Okay, so now I'm going to distribute this. Keep in mind, when you have an exponent raised to a power, you end up just multiplying those exponents. So this is going to become 2 to the 2x equals negative x plus 3, because I multiplied these, because you're raising the negative 1 to x minus 3. Okay, so now I can use this, right? Since b to the x equals b to the y, I can just make x equal to y. So 2x equals negative x plus 3, and you can solve this sucker and solve it, and you get x equals 1. Well, what if I have another example where I have 40 to the x equals 11? Well, I can't make 11 equal to 4 or 2 or whatever. So in that case, it's going to be a type 2 where I have to take the log of both sides. So I know that I can get rid of this 4 and get just x if I take 4 to the x and take the log base 4 of it, because log base 4 of 4x, 4 to the x, is going to just be x. Because remember, it's going to be 4 raised to the what equals 4x. Well, x. So your answer is x. The issue is I've got to take the log base 4 of 11 then, since I'm taking the log of both sides. So log base 4 of 11, okay? If you have a calculator that can do this, fantastic, just calculate it. Or we can use what we used before, which is your change of base formula. And you can say log base 11 over log base 4, solve it, and you get x equals 1.73 rounded. Okay, so there are 4 more questions here. Decide if it's going to be a number 1 or a number 2, and then solve accordingly. So figure out if you can get the same base for it. If you can't, then just take the log of both sides. All right, so let's go over my work. So here, I can't have the same base. I don't know what 7 and 18 would have the same base of, so I'm going to take the log of both sides. I'm going to take the log base 7 because that will end up giving me just 3x, because log base 7 of 7 to the 3x, 7 raised to the what equals 3x? Sorry, 7 raised to the what equals 7 3x to the 3x? 3x. Then I need to take the log base 7 of 18, and I should have put 18, not 8. I apologize. Okay, so this should be 18 as well. And then you'd actually plug this into your calculator, and then you divide it by 3, and so that actually ends up being 0.495, not 0.356. Sorry about that. But if you did 8, then that would be your answer. All right, for number 2, I got 8 and 32 as bases. So I actually know that I can make that equal to 2. They can have the same base. So to get 2 for my base, I'm going to take 2 and cube it. Still have it raised to the x minus 1. And then for 32, 2 to the 5th, and then raise that to 3x minus 2. So keep in mind, because I'm raising the third exponent to the x minus 1, I'm going to end up multiplying my exponent, so I get 3x minus 3 and 15x minus 10. Now I know that I can set the x and y equal, so I write that, and then I can actually end up solving it, and I get x equals 7 over 12. For number 3, again, I recognize, I can actually have the same base, and it's going to be 6. So here, 36, to make it the same base, it's going to be 6 squared. Here, to make 1 6, 6, it's going to be 6 to the negative 1. So I'm going to multiply my exponents. I get 10x plus 4 equals x minus 11. Okay, I'm going to set those equal because they are, and I can solve it, and I get negative 5/3 when I reduce. For the next problem, I have 2 to the 0.1x minus 5 equals 7. So I'm going to move my 5 over first. And I look at these, and I can't have these have the same base. So this is going to be a situation where I need to take the log of both sides. So I'm going to take the log base 2 of 2 to the 0.1x, set that equal to log base 2 of 12. And so what that would give me, this would just be 0.1x, because 2 to the what equals 2.2 to the 0.1x, well, it'd be 0.1x. That equals, well, I solve this in my calculator, and then you divide both sides by 3.58, and I get 35.8. All right, what if I have a situation where I have 2 logs on either side? Keep in mind, I'm not going to have another number, adding another number on either side, or subtracting. What if I just have my logs? Well, if those logs are equal and they have the same base, then I can just say that their x and their y are equal. So for example, if you look here, if I give you this problem, notice that the logs are equal, they have the same base, so I can just set 5x plus 9 equal to 6x, and my answer is 9. Now the only issue with this is when you're dealing with these types of problems, you got to go back and check to make sure your answer makes sense. Meaning, if this value would give me a value in here or here, that would be negative. Remember, you can't take the log of a negative number. So this number does work because it doesn't give me a negative number, so I'm fine. For example, number 2, again, they're equal. So I'm just going to, x and y are equal to each other. So I'm going to solve this, and I get x equals 8/3. Okay. So now, same thing applies for ln, by the way. Stop the video and do these 2 practice problems. All right, so let's look at these. So x plus 19 equals 7x minus 8. I solve it, I get x equals 17/6. I go back, plug it in. I make sure that both of these values, x plus 19 and 7x minus 8, would be positive. They are. My answer works. For number 2, same thing, set them equal. I solve this, and I get x equals 3. Now here's the problem. When I plug back in x equals 3, 3 times 3 is 9, minus 10 is negative 1. That does not work. So that answer is not valid. That's an extraneous answer. So there are actually no values. This does not have a solution. All right, let's look at some examples of solving some more complex logs. So if I give you this and I ask you to solve it, okay, let's just use our properties of log. So the first thing that I can do, I want to isolate my log. So I'm going to move the 1/3 over by multiplying both sides by 3. I get log base 5 of 12x equals 6. Now I'm just going to solve for my x. I'm going to say 5 to the 6, so 5 raised to 6 equals 12x. And then I can just divide both sides by 12, and I get my answer, which is this value, or 1,302.1. So I'm just using my values or my principles of logs, but it is a little bit more complicated. For this one, in order to solve this, I recognize the fact that I'm going to have to use my product property. So I'm going to multiply negative x by x plus 10. Okay? So log base 4 of negative x squared minus 10x equals 2. I'm going to take 4, raise it to the second power, and that's going to equal negative x squared minus 10x. I need to solve for x, so I'm going to have to use, because this is a quadratic, what I'm going to have to do, I'm going to move x squared and 10x over, and then I'm just going to factor this. If it's not factorable, then yeah, you might have to use your quadratic formula, which is fine. But I factored it, and I solved it, and I got negative 8 and negative 2. Now keep in mind, for all of these, I need to go back quickly and make sure that these answers work, meaning it doesn't give me a negative value in my log. So negative 8, when you plug it in here and here, does not give me a negative value. Negative 2, so both of those work. Same thing for example 1. For example 3, I'm going to subtract negative 3, or I'm going to subtract 3 from both sides. Okay, and then I need to get ln all by itself, so I'm going to divide by 4. Now I can take e, because remember ln is log base e, so e raised to the 18/4, that's going to equal negative x. So when I solve this, it's going to be negative e raised to the 9/2. Okay, so keep in mind I'm going to plug this back in here. Notice this is negative x, so that would give me a positive e to the 9/2. That would be a positive value, so that's your answer. And I believe instead of just 90.017, that should be negative 90.017. Okay, here are my 3 practice problems. So I want you to pause the video, and I want you to solve for x using your properties of logs. All right, let's look at this. So I'm going to solve this one. So I want to solve for x. I'm going to say 2 raised to the 6 equals x minus 4. 2 to the 6 is 64. I move my 4 over by adding, and I get x equals 68. For number 2, I'm going to first use my product property. So 3x times x minus 1 equals 3. So it would be log base 6 of 3x squared minus 3x equals 3. Now I'm going to use the fact that 6 raised to the 3rd equals 3x squared minus 3x. I need to solve for x, so what I'm going to do is I'm going to move over my 6 cubed. So it's going to be 3x squared minus 3x minus 216 equals 0. Now I'm going to, before I freak out and think, oh my gosh, I can't do this, I'm going to pull out what they all have in common, which is 3. It's going to be 3 times x squared minus x minus 72. Now I recognize, I can factor this. It's going to be x minus 9 times x plus 8 equals 0. Now when I solve this, x equals 9 and negative 8. The issue is when I go back and double check this, negative 8 would give me a negative value in my log. Okay, and here as well. So that value does not work. It's an extraneous solution. So my answer is just x equals 9. For the final problem, okay, I'm going to first condense this. So it's going to be x minus 9 times x minus 3 equals 2. Okay, I'm going to multiply them out, spoil them. So x squared minus 12x plus 27 equals 2. Now I'm going to take 3, raise it to the second. That's going to equal my value here. I'm going to scoot the 9 over by subtracting, and I end up getting x squared minus 12x plus 18. Now you can try and factor that. You're not going to get an answer because there's no way to really factor it. So I have to use my quadratic formula. When I plugged in all of my values, I got 12 plus or minus the square root of 72 over 2. I simplified this by pulling 36 out. Okay. But then I recognize that these all have 2 in common, so I can further simplify it by saying it's 6 plus or minus 3 rad 2. Now the issue is when I go back and plug these values in, if I take 6 minus 3 rad 2, that would give me a negative value here. So that does not work, so that answer is not an option, and instead your only option is 6 plus 3 rad 2. Okay? So the hardest problem for these is just making sure you don't make a mistake because there's so many steps to them. So just work as carefully as possible.